When we said what the type of age variable is, Python said that it's an integer. Now, how many types of numbers are there? Well, in Python, there are three types of numbers: integer, float, and complex numbers. So these are the only three types of numbers possible in basic Python variables. Now, we have seen examples of age equal to 23, that's an integer. Now, an integer cannot have decimals. Like, for example, weight. Weight can have decimals, right? So I am 102.5 pounds or 75 kilos or 75.5 kilos or 0.3 kilos. So an integer and float are different in that an integer cannot have decimals while a float can have decimals. We don't most of the time use complex numbers, so this is very rarely used. Probably if you go back to your math classes, you can understand what complex numbers are. So an example is 2 plus 3j. So this part is called the imaginary part, and this part is called the real part. But unless there is a specific use or a specific use case, mostly scientific in nature, complex numbers are rarely used. So we are not going to discuss too much about complex numbers, but we'll focus mostly on integers and floats. So one more example of an integer is, say, discount. So typically you'll have a discount of 30% or 35% or 50%. You typically don't see discounts of 30.5%. Technically it's possible, but you don't. Now, how big can an integer get? If you are used to the C language or any other primitive languages, for example, if you say age, and then you have to prepend it with int age equal to 24. This is in C language. There is a limit to how much this variable age can hold. There are a variety of choices that dictate how big this variable can get, like the type of architecture you're running this program on, and the way you define this variable, so on and so forth. But in Python, since you don't specify that it's an integer, it is interpreted by Python as an integer. There is no limit on the size of the variable, meaning, for example, this is just 2 digits, right? 2 digits, 2 and 4. What about an integer that's huge, like 24 billion? Can age be 24 billion? Yeah, probably. The age of the universe. I don't know what's the age of the universe. I think it's 13 billion. But you get the point. The variable integer in Python can hold a number that can be as big as you want. In fact, you can try it. Let's do a quick calculation just for fun. You see this? Age of the universe is 13 billion. 13 followed by 9 zeros. And if you want to calculate the age of the universe in seconds, you're going to make this number even bigger, right? So the age of the universe in seconds is age of the universe, which is 13 billion that we have defined here, multiplied by how many seconds there are in 1 year, which is 365 days multiplied by 24 hours per day into 60 minutes into 60 seconds, right? And that's going to be an even bigger number. And still, Python can hold that number. You see, it's pretty big, right? It's much more beyond billions, and it still holds that number. The point being, Python's integer variable can hold an integer that's as big as you want. If you want, you can try this. Let's copy this, go to the Jupyter lab, and age of the universe is 13 billion. Now, you can use this variable in another variable. So we are creating another variable, age universe underscore seconds, to indicate that this is going to contain the age of the universe in seconds, equals, we're going to use the previous variable that we have already defined, age underscore universe, and then multiply that by 365 days, and each day has 24 hours, and each hour has 60 minutes, and each minute has 60 seconds, right? And let's run this. Age underscore universe underscore s, shift enter. See, that's a big number, right? It's still an integer, but a big number. So there are 2 points that I'm trying to make here. One being, the integer variable in Python can hold large numbers or small numbers, either way. And the second point being, you can use one variable to compute something else. For example, we have declared one variable here called the age of the universe. And then we are using that variable and then doing some other calculation to store it in another variable. We'll see more examples as we go forward, but I just want a glimpse of how to manipulate variables. Alright, now let's do something. Let's again calculate the age of the universe in months. Now when you divide the age of the universe by 12, you get the number of months, right? Age of the universe in years divided by 12 will give you the number of months. So the age of the universe is 13 billion. And then what we're going to do is age of the universe in months equals age of the universe divided by 12. Right? Age of the universe in months is equal to, I think that's thousands, millions, that's like 1 billion months. Now you see that this has a decimal component, .33333, right? What kind of a variable is this variable now? The one that you have obtained after dividing the age of the universe by 12. Now this was an integer and you have divided that by 12, and what did it result in? It resulted in a number that has decimals. Now what kind of a variable is that? Type of age underscore universe underscore m. Shift enter. And you see that's a float. Python has automatically created that variable as a float. And it has done it because it knows that when you divide an integer by another number, it will result in a float. So a floating point number is something that has decimals in it. Now, what if you did something like this? It does not necessarily have to result in decimals. Python does that conversion automatically. So the point I'm trying to make is, for example, the age of the universe was 13 billion, right? 13 billion. What if you divided this by 13? So it will not result in any decimals. It will result in a whole number, right? Let's do a shift enter or play. And then it resulted in a whole number, but Python has added a .0. Why? Because when you divide a number by a number, one integer by another integer, one integer by a float, the resulting number could be either an integer or a float. And since we have left it to Python to decide what it's supposed to be, we didn't explicitly declare this as either an integer or a float. When you divide a number by a number, automatically the result or the resultant variable is going to be implicitly declared by Python as float. And that's why you see a .0 here, because it's not required, right? When you divide 13 billion by 13, you get a whole number. But since Python doesn't know what the result is going to be, it has declared it as a float. So even though it does not have decimals, Python has certain rules by which variables has to be defined. Now just to complete things, let's also declare this complex number. So the way a complex number is declared is something like this. So when you say v equals 1 plus 2j, 1 being the real part and 2j being the imaginary part. Now if you type in type of v, shift enter, Python knows that it's a complex number. It's just because of this additional imaginary part. But if that was not there and did a shift enter again, v equal to 1, now if you say type of v, that will be an int. So based on the way you define your data, your variable type will automatically be declared by Python. And that's why Python is called as a dynamically typed language. Meaning you don't have to tell Python what kind of a variable it is. It will automatically interpret it. This is unlike C or C++ or Java, where you have to explicitly type and tell the language that it's an integer or a floating point. If it is an integer, how big it is. If it is a string, it should be declared as a string. So those are examples of statically typed languages, C, C++, Java. Python, on the other hand, is dynamically typed, meaning type of the variable is automatically or dynamically determined by Python.